just to warm up with your partner. You're going to answer A, B, C, D here for all 3 days. This is the same dog as yesterday's lesson. Remember the owner went in to get some Starbucks, chained the dog up, and the dog walked around and stuff, right? Day 1, 2, or 3 is what you got yesterday. So you're going to answer, again, A, B, C, D for all the days. Then you're going to answer 2 and 3 before we go over it. And we'll be able to reference this during the lesson and point some things out. It'll be cool. For number 1, who can raise their hand and tell me how far the dog was from the post 60 seconds after? Ellie?
4 feet.
So for all 3 of them, right?
Yeah.
For day 1, 4 feet for day 1, 4 feet for day 2, 4 feet for day 3. Okay, that's this point right here, right? Okay, problem number 2, or 1B. How far from the post when the owner left? Will?
1.5 every day.
1.5 feet, 1.5 feet. Every day, right? Every day. That's what Drake would say. Every day. Right there. Okay? C. Return 160 seconds after you left. How far was the dog away? Heidi?
For day 1, it's about 3.7 feet.
Right. Okay, so day 1, you go to say 3.7. Okay.
For day 2, it's like 4 feet.
Okay.
For day 3, it's like 0.5 feet.
Got it. Everybody see where I pointed that out next to the grass? Okay. So that was C. I'll put like C next to graph. And then D, how many seconds passed before the dog reached the furthest point? Micah?
For the graph 1 is about 45 or 50 seconds.
50 seconds, okay.
For the second day, it's about 35-ish seconds. And then for the last day, it's about 10. Like 3 seconds.
Yeah, I said 2 seconds. But yeah, same idea. Ish, right? All those are ish. Cool. So number 2, consider the statement. The dog was 2 feet away from the post after 80 seconds. Do you agree? Let's take a vote. Do you agree? Raise your hand if you agree. Yeah, Elliot, why do you agree?
In day 3.
Oh. Elliot's seeing that spot right there. But, how did you know to look at day 3?
I looked at all of them.
You looked at all of them. So the question, if we're considering 3 days, was the question a bit ambiguous?
Yeah.
Meaning like, we don't know? Like, you could say like, I don't know. Some days it did, some days it didn't. That's a little confusing, wouldn't you agree? You think that's a bad question?
Yeah.
I think maybe it is. I don't know. Maybe there's a point to this confusion right now. Because it didn't happen every day, did it?
No.
If they were talking about day 3, could have answered it pretty easy.
Yeah.
If they were talking about day 1 or 2, could have answered it pretty easy.
Yeah.
But they just asked it, and there's 3 days. I'm kind of confused. Okay. What was the distance of the dog from the post 100 seconds after the owner left?
I don't know.
Which day?
Three of them.
Yeah, okay. So, the point we're going to make with these 2, I'm just going to write this. Which day? And you probably answered stuff and you tried, like, I did this specific day or I did all 3 days. But the big point here is 2 and 3 don't say which day. So I'm a bit confused. But you'll see what's up in a second, okay? It's supposed to be like, hey, that's confusing. Well, let's find a way to make it less confusing. There's a way. And the way is called function notation. I want to point out this, right? It is fun. Very fun. All right? So it's a way of writing the inputs and outputs. When we see this right here, we actually say f of x. That's like you'll hear that stated for that, f of x. And it just means the function of x. And we know that x is which variable, dependent or independent?
Independent.
Yeah, look at that. So the function of the independent variable gives us the output, the dependent. So again, it's going to be purely organizational. You can have anything of x. It's not always f. F is kind of base. It's the name of the function. You'll also see stuff like g of x, h of x, b of x, like anything of x. And it just means that function, okay? You'll see. And it's great for organization because if you just have a bunch of y equals things, it's hard to differentiate. So this is on your handout. We're going to work on this handy notation, and we're going to stay in the mindset of all these dogs. So just a reminder, when we have function notation, we're going to have a different function for day 1, day 2, and day 3. And we know they're a function because the distance away from the pole is a function of time. Okay? So what we know then is the independent variable is time. The dependent variable is the distance from the post. We already established this yesterday. So when I have the distance from the post 60 seconds after the owner left on day 1, that is saying day 1 is function f. That's saying f of 60. The function of 60 literally means the distance from the post 60 seconds after the owner left. So this needs to be in your table right there, f of 60.
Wait, but why can't it be like 16?
It isn't, because f of 60 says the function of an input 60. The output of f of 60 would be the distance. We don't know the distance, so we're just saying f of 60. So day 2 would be what? G of 60. And day 3 would be H of 60. So these all just say, so what it says is, at day 1, 60 seconds after the owner left, day 2 after this 60 seconds after the owner left, and day 3, 60 seconds after the owner left. We all good with that?
Why are we skipping A through E as far as variables?
Well, it usually starts with F, just I think because function of. But it can be any letter. This is just the assigned letters. FGH will be the most common 3 you'll see
Wait,
though.
so this 60 is the output?
It's the input. 60 seconds.
60 seconds is the input for.
Yep. So distance from the post when the owner left. So I'm going to do F of here because it's first day. How much time happened at that distance? 0 time. So I've got F of 0. I've got G of 0. And I've got H of 0. Okay. And again, this is just saying day 1 at 0 time, day 2 at 0 time, day 3 at 0 time. That would give you the distance.
Wait, so all the F, G, and H are is just saying like
Day 1, day 2, day 3. So for C, the distance from the post 150 seconds, we'd have F of 150, G of 150, and H of 150. Again, it's saying 150 seconds after for day 1, 150 seconds after for day 2, 150 seconds away for day 3. And you might be like, yeah, this seems pretty easy. Well, let's start interpreting stuff. So instead of writing the function, let's take the function notation and say what it means in context. So F of 15, which day are we talking about?
Day one.
So on day 1, are we talking, is 15 time or distance away?
Away.
The distance,
How do you know it's distance?
it isn't. The dog is away after 15 seconds.
How do you know it's seconds?
I know it's seconds because it's f of x, x being the independent variable. So the function needs to be of time. The function of time is distance. That's why we made a point of making those statements yesterday. So the function of 15, so the function of 15 seconds is the distance away. So if we had an equal sign, we could state the distance, but this just says f of 15, which means the f of tells us on the first day the distance away the dog was after 15 seconds. Do we know the distance? No, if we had equal something, we could state the distance. I'm going to use a different color just because there's not a lot of room here just to differentiate. So for the second one, G of 48, who would like to give it a try? Finn.
On day 2, the distance away is after 48 seconds.
The distance away at 48 seconds. Yeah. That's good. And who would like to give C a try? All right, Will.
The distance the dog goes away from the pole after T seconds.
Okay, so distance, dog is away from pole
On day 3.
at T seconds on which
day three.
on day 3. How do you know day 3?
Because it's H.
Because it's the function of h of. Okay, so again, are you guys seeing that organizational aspect of all this?
Yeah.
Did you guys notice on the warm-up, those last two, we didn't know which day they were talking about if it didn't say anything? Now, no discussion. We know which day. F of t is day 1, G of t is day 2, H of t is day 3. Okay, so for number 3, G of 120 equals 4 means on the second day, 120 seconds after the owner left, the dog is 4. So we got more information. I want you to try to make those statements for A, B, and C on number 3, please. We'll let you branch out on your own a little bit here. So who would like to give 3A a shot? I see Heidi.
On day 3, after 40 seconds, the dog overlaps. The dog is 4.6 feet away from the post.
Got it. So Heidi said on day 3, at 40 seconds, the dog is 4.6 feet from the post. How did you know it was day 3, Heidi?
Because it's H.
The function of H. So would you say in terms of communication, pretty solid. If H is day 3, H of 40 means day 3. Cool. Next one, Evan.
On day 1, the dog was 5 feet away from the pole at T seconds.
The dog was 5 feet away at T seconds. How'd you know it was day 1?
Because it says F.
F of T. Excellent. And Elliot.
For C, on day 2, the dog was D feet away from the pole in T seconds.
And how did you know it was day 2?
Because it was G of T.
It was G of T. Excellent. I thought it was going to be because the sign in the office said day 2. I'm joking.
They have a sign there? Yeah, they have a sign.
There's a sign.
Yeah. You're going to be able to roll through this yourself, and it's going to be pretty quick. We've got rule B. We've got rule P. Complete the tables using inputs and outputs of people and their birth dates, and then answer the questions, please. So, for rule B, we're going to take a name and get a birth date. So, would anybody like to? Annika, what's a name and birth date?
I have Julia, February 16th.
Okay, and I would put like a last name. This is intended to be like a specific person, not just like a name. Okay, and Elliot.
I have Oliver, December 11th.
Okay, and there's a bunch of other ones. Okay, let's go to rule P. A date. Let's just go a fun one. I think June 1st. And who has a birthday on June 1st?
I don't know.
I do. I do.
And so does Willa. So does Willa.
What?
Birthday buddies.
So does
Ramsey.
So does John.
Oh, Willa does?
Willa
I
does.
recall, I believe
Okay.
one on June. Mike,
So this works. This works out. So problem number 2. If you use your name as input B, so that's over here. Okay, how many outputs are possible for your name? 1. There's only one output. How do you know?
Because there's only one year.
You only have one birthday.
You only
Yeah.
have one birthday.
You only have one birthday.
Unless if you were born over the course of like 2 minutes. Like at midnight. Unless you had 11:59. That didn't work as well. One of my friends was born on Wednesday.
If you were to use your birth date for input P, like mine, June 1st, how many different outputs could there be, Willa? Multiple. Well, theoretically, there's not infinite people. Okay? Explain how you know.
Go back in time.
theoretically, 365.
On any birthday, there could be a bunch of different people. So, only one of these is a function. Raise your hand if you think rule B is a function. Raise your hand if you think rule P is a function. Interesting. The answer is rule B. Each input has only one output. Now, First Hour came up with something cool. They're like, well, what if 2 people's names are John Smith? Okay, so that'd be true by name, but the input is like the person. So this John Smith only has this one birthday. This John Smith only has this one.
What if they have the
Okay?
same birthday?
Last, 5. For the function, let's write 2 input-output pairs. So what is the independent and independent variable for rule B then? Someone help me out. Let's try to get it. Finn, let's try to get this in a function statement kind of.
The person's name.
The person's name is a function of the date?
No.
The date.
The date is a function of the person, right?
Right.
Okay, so, for example, we have the function of Julia. I should uppercase that J. Julia is a proper noun. Is what? February 16th. And the function of Oliver is December 11th. So notice, the independent variable is what the function's of. The dependent variable is the output of that function. So this is function notation for rule B. The other one cannot be a function because the input or the birth date can have a lot of different outputs. Each person only has one birthday. That is a function. All right, you are going to show me your lesson summary to get the homework today.